This is SKY2UM, and I'm the Principal and Director of Sky Academy, and we've been going through basic algebra, and we've just started dipping our toes into the water when it comes to doing factorization. Factorization, of course, is the opposite of expanding brackets. We are now bringing factors out so that we have brackets multiplied by more brackets. So we're going to start doing that by grouping in pairs so that we have a 4-term algebraic expression, and we are going to group pair by pair, alright, so that we end up with the product of two binomials. Okay, so let's have a look at this. If you've got ax plus ay plus bx plus by, what you can do is take the two a's out of the first two terms and you're left with a outside of x plus y, and then you can take the two b's out of the next two terms and you've got b outside of x plus y. What you'll notice is you've got two products or two expressions of which x plus y is common to both. Yes, x plus y is common to both ax plus y and b outside of x plus y. You can take what's common out. So let's take the x plus y out and bring it there, which means that this a can go there and that b can go there. That is basically how you group in pairs. Okay, factorizing by grouping in pairs. So we're going to dip our toes in the water when it comes to this stuff, and I've got some questions up on the board. Alright, so let's do the first one. A outside of x plus 2 plus b outside of x plus 2. You can see that the x plus 2 is common to both. X plus 2, x plus 2. We can bring that out the front. If you take the x plus 2 outside of this term, you're left with a, and if you take the x plus 2 outside of this term, you're left with b. So it's x plus 2 outside of a plus b. Now, you can do that with expressions with two terms, or you can do it with expressions with three terms. So see how a plus b is common to all three terms? You can take a plus b out, and you're left with, if you take a plus b out of this term, you're left with p. A plus b out of this term, you're left with plus q. Take a plus b out of this term, you're left with minus r. And so the answer for this, when you factorize it, will be a plus b outside of p plus q minus r, close brackets. You do the same thing for this one. It's what's common to both is 2b minus 3c, and you're left with 3a minus 2b. Okay, that's just to reinforce it. This is where you start applying two steps to the grouping in pairs work, alright? Let's take out what's common to this one. What is common to this one, by the way? Well, if you look at it, a is common to both. So you take a out and you're left with x plus 4. Take b out of the next two terms and you're left with x plus 4. So you take x plus 4 out of both and you're left with a plus b. Now, you might be asking me, well, what happens if these two terms aren't the same? Well, the answer is, if these two terms aren't the same, you can't group in pairs. And if they're not the same, then it just goes to show you that either you've done something wrong, or you've tried to group in pairs on a question where it's not supposed to be applied. Okay? So, in terms of grouping in pairs, you can only do this if these two terms are the same. Okay, the x plus 4 is common and the x plus 4 is common. Alright, so I'm going to do this question here where you might go, hold on a tick, these two terms aren't the same, and it'll be because you haven't done something right. Okay, so I'm going to deliberately make a mistake on the next one. Okay. If you take out the x, you're left with x outside of x minus y. And if you take out the z, you're left with plus z outside of minus x plus y. And you might be thinking, they're not common, okay? Well, in this situation, what you've got to take into consideration is that the common factor is not z, but it's a minus z or a negative z, which means that you have to flip this sign and you also have to flip this sign. By doing that, what you've done is you've allowed yourself to answer this question now, because the common factor is x minus y. You've produced that. X minus y outside of x minus z. Okay, so just be careful with questions like that, where you might find that by going one step, you might find that the binomials are almost the same, but you might find that they're out because the signs are flipped around, which means that you have to take out a negative in the second binomial. So just be careful of questions like that. Let's do a question like this. What's common to these two is p plus q, or sorry, pq, which means that pq, if you take out pq out of p squared q, you're left with p, and if you take out pq out of pq squared, you're left with q, right? Take out the 5, right, because 5's common to both, and you're left with p minus q, and then your answer is pq plus 5 outside of p minus q. Well, it should be the other way around. P minus q should be here, and p squared plus 5 should be there. So these should be swapped around, but it just goes to show you, you can do it this way or the other way, and it'll just be the same expression, okay? Because when you multiply, you can do a times b, or you can do b times a, and it'll still be the same thing. Let's have a look at this expression, because it does look like you can't really do it with this one. 2x cubed minus 2x squared plus 2x minus 2. Well, let's have a go. What's common to both? What's common to both is 2x squared. You take the 2x squared out and you're left with x minus 1. And you take the 2 out and you're left with x minus 1. X minus 1 is common to both. 2x squared plus 2, alright, is what's left over. And what you can do is take out another common factor from here, which is the 2. Alright, so let's take the 2 out, and you're left with 2 outside of x minus 1, x squared plus 1. Okay? So, have a go, practice doing some questions involving grouping in pairs. A lot of this stuff should be revision from year 9 and 10 work, or even year 8 work for some of you guys. So just go through that, familiarise yourself with that, because this stuff will come in handy in the rest of the course. So thank you very much for watching.